Today, we're going to peel back the layers on one of the most powerful technologies out there, artificial intelligence. We're going to build it all up from the ground floor, piece by piece, so you can really see what's happening under the hood. Let's jump right in. So, what is AI, really? At its core, it's all about creating machines that can think and act like humans. And this goes way beyond just being a glorified calculator. We're talking about real skills here, like reasoning, learning from things that have happened before, and solving some really complex problems. It's about building machines that can understand their surroundings and then take action to get something done. And this quote right here, it really shows you just how big the idea of AI actually is. It's not just about shiny robots from the movies. Nope. Anytime we build something that tries to copy a complex human skill, whether that's recognizing a pattern, making a judgment, or learning, that falls under this giant umbrella of AI. It's a goal we've been chasing since the very early days of computing. Now, AI might feel like it just popped up yesterday, but its roots go way, way back. The ideas that power today's systems were actually planted decades ago. I mean, think about it. All the way back in 1943, we had the first mathematical model of a neuron. Then in 1950, the one and only Alan Turing was laying down the groundwork for machine intelligence. And by 57, the perceptron gave us a sneak peek at what neural networks could become. The ideas have been around for a long time. It's the sheer computing power that's finally caught up. Okay, so if AI is this incredible destination we're trying to reach, what's the vehicle that's actually getting us there? Well, that brings us to the engine room, machine learning. This is a really key point. Machine learning isn't separate from AI. It's a part of AI. In fact, it's the main way we're making AI happen today. Instead of programming a computer with a specific instruction for every single thing it might encounter, machine learning is about creating algorithms that can learn for themselves just by digging through tons and tons of data. This right here shows you what a massive change this is. You see, in old school programming, a person sits down and writes out all the rules, like, if this happens, then do that. But with machine learning, we totally flip that script. We just give the machine a mountain of data. Here are the inputs, here are the right answers, and we tell it, okay, you figure out the rules that connect them. Before we get any deeper, let's just get on the same page with some of the lingo. First up, an observation. That's just a single piece of data, like one customer or one sale. Features are the different inputs we use to make a prediction, like the customer's age or what they bought last time. The target is a thing we're trying to predict. Will they buy this new product? Parameters? Those are the internal dials the model tunes all by itself as it learns from the data. And last, we have hyperparameters, which are the settings that a person, a human, sets up to guide how the model learns in the first place. All right, so we know the what and the why. Now let's dig into the how. It turns out there are really three main ways that machines go about learning from all this data. And here they are: supervised, unsupervised, and reinforcement learning. Each of these is perfect for a different kind of problem and a different kind of data. So let's break them down, starting with the one you'll see most often: supervised learning. The best way to think about supervised learning is like studying with a super detailed answer key. You give the machine a massive data set where every single piece of information is already labeled with the correct answer. It's kind of like using flashcards where you have the question on one side and the answer on the other. The machine's job is to figure out the connection between the two. Now, within supervised learning, you're usually doing one of two things. The first is classification. That's where you're trying to predict a category. Is this email spam or not spam? Is this picture a cat or a dog? The second is regression, and that's when you're trying to predict an actual number. What's the price of this house going to be? Or how many widgets will we sell next month? And here's a really simple way to picture how classification works. The model gets a bunch of data points that are already labeled. You've got your A's and your B's. Its entire job is to learn how to draw a line, a boundary, that perfectly separates these two groups. That way, when a brand new unlabeled data point shows up, the model can say with confidence, aha, that belongs over on this side. Okay, but what if you don't have an answer key? What if you've just got a giant pile of data with no labels at all? Well, that's where unsupervised learning comes into play. Its whole purpose is to look at all that raw data and find the hidden patterns and structures all on its own. It's like someone dumping a huge box of Legos in front of you and saying, sort these, without telling you how. Two of the big jobs here are clustering, which is all about grouping similar things together. A classic example is dividing customers into different segments based on how they shop. And then there's something called dimensionality reduction. It sounds fancy, but it's really just about squishing the data down to its most important parts and getting rid of all the extra noise. And our third and final way of learning is reinforcement learning. This one is all about learning by doing. The best analogy is training a pet.
You have an AI agent that you put into some kind of environment, and it learns by trial and error. When it does something that gets it closer to its goal, you give it a reward, a little digital treat. The agent's mission is to figure out what sequence of actions gets it the most rewards over time. This is exactly how AI has mastered incredibly complex games like chess and Go.
So we have our learning strategies, but what's the actual machinery that's doing all this work? Well, that brings us to the core architecture that's powering the most advanced AI we have today, artificial neural networks. Artificial neural networks are basically computing systems that are, and I say this loosely, inspired by the way our own brains are wired. Just like our brain has billions of interconnected neurons passing signals around, an ANN has nodes or artificial neurons that process information. These networks are the absolute foundation of what we call deep learning. Even a simple neural network has this basic three-part structure. You've got your input layer, which just takes in the raw data, like all the pixels in a photo. Then you have one or more hidden layers. This is where the magic really happens. Each layer of neurons looks for increasingly complex patterns in the information passed to it from the layer before. And finally, you have the output layer, which takes everything that's been learned and spits out the final answer, like cat or dog. I'm sure you've heard the buzzword deep learning a million times. But what actually makes a network deep? It's actually a pretty simple concept. When a neural network has more than one of those hidden layers, and modern networks can have hundreds, even thousands of them, we call it a deep neural network. That's it. That depth is what lets it learn unbelievably complex things.
And this leads us to the absolute superpower of deep learning, what we call automated feature engineering. See, with older methods, human data scientists had to spend ages manually figuring out what parts of the data were important. But deep learning networks, they do this automatically. They learn the most useful representations of the data all by themselves, straight from the raw input. And that is why they are so incredibly good with messy, complicated stuff like images, sound, and natural language.
Wow, okay. We've journeyed from the 30,000-foot view of AI all the way down to the nuts and bolts of how a neural network works. So let's do a super quick recap to tie it all together. So here's the big picture, the cheat sheet. AI is the grand goal, making machines smart like us. Machine learning is the engine that drives us toward that goal by learning from data. That engine works in three main ways: learning with an answer key, without one, or through trial and error. And for the really, really tough problems, we use a supercharged version of that engine called deep learning, built on those brain-inspired neural networks. We've covered the foundations of how these incredible systems actually learn. And that leads to a pretty fascinating final question. Now that we understand the mechanics of how to teach a machine, the real challenge becomes, what should we teach it next? What problems do we want it to solve? Something to think about. Thanks for tuning in.